Hello guys, you're welcome to Nisike Academia. So if you've not subscribed to this channel, do well to hit the subscribe button and subscribe in order for you to get notifications of our subsequent videos and of course classes. Alright, so in this video we are going to be looking at how to balance chemical reactions using the algebraic method. Alright, this is a very crucial aspect of chemistry that enables us to know how to balance neutral compounds, neutral reactions that of course are unbalanced using algebra. Okay, I know that probably the only place you've heard of algebra is in mathematics, but then I'm here to tell you that algebra can also be applied in chemistry. Okay, so the steps that are involved in balancing chemical reactions using algebraic method are as follows. The first thing you would have to do is to, of course, when you have a reaction, okay, you apply the steps, okay, and that's what we'll be doing right away. And of course, I would be giving you the questions, I'll be giving you the reactions that will be balancing. So let's start with this reaction. So let's say we have a reaction, let's say PCl5 plus H2O to give us H3PO4 plus HCl. Okay, now looking at this reaction, you realize that phosphorus here is balanced, but chlorine here is not balanced. Chlorine is 5, chlorine is 1 here. Hydrogen gas is 2 here. Of course, hydrogen rather is 2 here. Hydrogen is 3 plus 1, 4. Okay, oxygen is 1 here, but oxygen is 4 here. If you look at it, it's not balanced. So what are the steps that can be applied in balancing a chemical reaction using the algebraic method? Now, the first thing you have to do is to add coefficients. Add coefficients. Now, these coefficients are in form of variables, okay, that would later turn to constants. So you use letters, attach letters to each of the compounds or molecules in the reaction. What I mean by variables are A, B, C, D, E, F, G, H, of course, letters of the alphabet. All right, so if you look at this reaction, you realize that there are about 4 entities. We have PCl5, we have H2O, we have H3PO4, and we have HCl. So what you do is to add these variables before each of the entities. Look at what I mean. So you say A here, you could say B here, you say C here, then you say D. Just write it like this. Write it in form of little subscripts, all right? But it should be in front of them, okay? Like just before the compound, like this. Just before the compound, just before the compound, like that. All right. So after writing this, of course, you proceed to the next step. But I want you to understand that the number of letters or the number of variables that will be used will depend on the number of compounds that are in the reaction. If you look very well, we have 1, 2, 3, 4. We have 4 compounds. If, for instance, we add 5, it will get to E. If it's 6, F, G, like that. Okay. So after attaching variables to each of these entities, the next thing is to list the elements in the reaction. All right, list the elements in the reaction without repetitions. So just list the element. The first element here is phosphorus, so you say P. The next element is chlorine, you say Cl. The next element is hydrogen, you say H. Okay, then the last but not the least element is oxygen, you say O. Then you put your columns like this, like this. All right, this is what you do. Okay, then after you must have done this, the next thing to do is to, of course, now relate these elements to the number of atoms and of course the variables that are actually behind the element where these particular atoms are located. All right, element or compound. Okay, look at what I mean. I will explain it clearly. Now, if we have phosphorus here, count the number of atoms on each side of the reaction. Okay, on each side of the reaction, that is the reactant side, the product side. Check the number of phosphorus on the reactant side, check the number of phosphorus on the product side. Then use that as a coefficient of the variable, okay, the variable for that element based on the compound or molecule where it exists in. Look at what I mean here. Phosphorus, how many atoms of phosphorus are here? One. Phosphorus is one. What is the letter before the compound where phosphorus is? The letter is A. So what you do, since phosphorus is one, instead of saying 1A, just say A. Okay, you just say A. Then go to the product side. Phosphorus is what here? Phosphorus is just one atom. What's the letter or what's the variable before the compound where phosphorus is? The variable is C. So you say A is equal to C. You've been able to take care of phosphorus. Do the same thing to chlorine. Chlorine is 5 here. What's the variable? Now, this variable A here covers for phosphorus and chlorine. This variable B covers for hydrogen and oxygen. This variable C covers for hydrogen, phosphorus, and oxygen. This variable D covers for hydrogen and chlorine. That's the idea. All right. So chlorine here on the reactant side have 5 atoms. So what's the letter? The letter before the compound where chlorine is A. So we say 5A. 5A. There's no chlorine here again. If, for instance, now a particular element appears in more than one molecule or compound on a particular aspect, that is whether on the reactant side or the product side, you say plus. For instance, now if chlorine were to be here, I would have written plus, then the number of atoms, and of course, before the variable where the element, okay, is assigned to. Like this B now, for instance, if there was chlorine here and chlorine were to be 2, I would have said 5A plus 2B. That's what I would have said. But there's no chlorine here, so we'll move to the product side. So this will be equal to chlorine is 1 here. The variable that actually has the compound where chlorine is in is D. The variable is D. So either I'm saying 1D, just say 5A equal to D. All right, then let's go to the next element. The next element is hydrogen. Hydrogen is how many here? Hydrogen is 2 here. The letter or the variable before the compound where hydrogen is B. So we say 2B. Then we'll go to the product side. Now hydrogen is also here, but hydrogen is 3. So we say equal to 3C. Then look at what I was saying. Hydrogen is not just here, hydrogen is also here. So we say 3C plus what? Plus D. Are you seeing it now? So hydrogen is in 2 different compounds. All right. So that's how we do it when a particular element appears in more than one molecule or compound. Now let's go to oxygen. On this side, oxygen is one atom of oxygen. Okay. So oxygen is 1, and the letter before the compound where oxygen is B. So we say B equal to oxygen here is 4. So we say 4C. This way, we have been able to arrange all the elements, and we have arranged them in a simultaneous manner where we have related the number of atoms of each of the elements with the variable that is behind or before the compound where these elements are located. So now the next thing is to assign the value 1 to the variable A. Now you may be asking, should it be A at all times? Yes, it should be A. Now why are we assigning a value to a variable? It's because all of them are unknowns here. You cannot get a value, okay, a value from all these unknowns if you don't assign a value to at least one unknown. And the unknown to always assign the value 1 is A. So you say let A be equal to 1. All right, it should always be A, and the variable which is A must always have the value 1. All right, take note of that. Take note of that. So after doing that, you say let A be equal to 1. After doing that, you now solve each of these equations. So now let's start with equation 1. Let's call this equation 1. Let's call this equation 2. Let's call this equation 3. And let's call this equation 4. All right. So having done that, so you say let A be equals to 1. So if A is equals to 1, let's start with the first equation. A is equals to C, right? So if A is equals to 1, is it not safe to say 1 is equal to C? So 1 is equals to C, right? So it's safe to say 1 is equals to C. So it means that C is what? 1 as well. C is 1 as well. All right? Then the second equation, we have 5A equal to D. 5A equals to D. We can get D from here, right? So I want you to understand that the fact that we have A does not mean that the next one we must have will be B. does not mean that the next one we must have will be C, the next one we must have will be D. No, it follows the reaction, the equations rather. It follows the equations. So that's the process and that's the pattern that you would actually move with. All right. So 5a is equals to D. So if 5a is equals to D, it's not safe to say that 5 times 1 is equals to D. So it means that D will be equals to what? 5. So it means that D will be equal to 5. All right, D will be equal to 5. We've been able to get D. But mind you, all these values will or may change along the line. Now, why will it change? If any of your variable while solving simultaneously gives you a fraction, then it will automatically change all the values you've already gotten. Now let's proceed. Let's proceed. Let's see if that will happen here. Now we have gotten A, we've gotten C, we've gotten D, which means that the next one to get is B. Now if you look at these two equations, you realize that we can get B from these two equations because we know C and D here. Here we know C. But the one that is the easiest is this fourth equation. So it's safe to actually jump. All right? It's safe to actually jump. If we use this equation and we use this equation, we'll still get the same value for B. We'll still definitely get the same value. Should we try it? Okay, let's try it. Let's check this first one as first before we go to the second one. Okay, let's check this equation 3 before we go to equation 4. Remember, what we only need here is B. Okay, so we say 2B equals to 3C plus D. So we say 2B will be equals to what is C? C is 1. So we say 3 times 1 plus 5. So this will be 2B equals to 3 plus 5. Believe you're following, right? Good. So it means that we say 2B will be equal to 8. So if 2B is equals to 8, it means that B will be 8 over 2, which will give us 4. All right, so it means that B is 4, right? Good. Let's check this. B equals to 4C. So we say B is equals to 4C. Let's check if it will give us 4 as well. All right, so it means that B will be equals to what is C? C is 1. 4 times 1. So B is equals to what? 4. Are you seeing? B equals to 4 here. B equals to 4 here. Okay, so check the one that will save you more time. All right, check the one that will save you more time to get the unknown. Okay, it's not compulsory that you must use all the equations. Once you have gotten all the variables that you need, there is no need proceeding, because proceeding will still give you what you already have. All right, so we did not get any fraction in this case. So what do? Let's go back. Let's check the original equation. The original equation was PCl5 plus H2O to give us H3PO4 plus HCl. All right, so A was 1, so there's no need writing 1 here. B gave us 5. We'll come here, we'll write 5. All right, remember it was the second compound that had B. Now C gave us 1. There's no need writing 1 here. Why D gave us, okay, D gave us okay, sorry, B gave us 4. Sorry, B gave us 4. Okay, it was D that gave us 5. All right, B gave us 4. Now let's check if it's balanced. Now we have phosphorus is 1 here. It's also 1 here. Chlorine is 5 here. Chlorine is 5 here. Remember, this 5 here affects both hydrogen and chlorine. This 5 here affects only chlorine because it's a subscript. Now, so phosphorus is balanced, chlorine is balanced. We are checking the rate of balancing if it's balanced from both sides, that is the reactant and the product. Now let's check. Hydrogen here is how many? 4 times 2, 8. So hydrogen is 8 here. Let's check if hydrogen is also 8 here. 3 plus 5. H3, 3 here plus 5, 8 as well. Hydrogen is balanced. Let's check if oxygen is balanced. So oxygen is 4 here, while oxygen is also 4. So it means that this equation is balanced. So you can pause this video and try some exercises that I will drop later on. But before I drop the exercise that you attempt, we'll look at an equation that will actually require us to change the variables like I explained, and an equation, an unbalanced reaction that will give us a variable that will have a fraction. All right, so let's look at an example. All right, so this is an equation a chemical reaction that is not balanced. Okay, as you can see, our carbon here is 2, carbon here is 1. All right, hydrogen here is 6, hydrogen here is 2, oxygen here is 2, oxygen here is about 3. All right, so now the pattern is this. Just like the previous steps that we've been applying, we attach variables to each of the compounds in this reaction. If you look at it very well, realize that there are 4 compounds as well. O2 is a molecule, by the way. So we say A, B, C, and D. The same pattern. Then what we do is to list the elements. So we have carbon, we have hydrogen, and we have oxygen. Then we'll put our columns like this. There are just 3 elements in this reaction. Don't repeat. Remember, I told you don't repeat. Okay? So now how do we navigate through this? Very simple, just like we did previously. We would relate the number of atoms of each of these elements with the variables before the compound where the elements are located. Now, let's start with carbon. Start from the first. Carbon is 2. The variable before the compound where carbon is A. So we say 2A. Okay? On the reactant side, we don't have carbon again. Go to the product side. Carbon is 1 here. So we say 2A equal to C. There's no other carbon there. Let's go to hydrogen. Hydrogen is 6 here. So we say, what do we say? We say 6A because hydrogen is in C2H6. All right. What is C2H6? C2H6 is ethane. Okay. This is a hydrocarbon. So 6A, going to the product side, we have 2 for hydrogen. And of course, the variable here is D. So we say 2D. Then for oxygen, oxygen is 2 here. So we say 2B equal to, oxygen is actually located in 2 different compounds, carbon dioxide and water. Of course, this is a combustion reaction where a hydrocarbon burns completely in presence of oxygen gas to liberate carbon dioxide and water. So oxygen here is 2. So we say 2, the letter here is C, 2C plus oxygen here is just 1. And the letter here, instead of saying 1D, we'll just say D. So we'll call this equation 1, call this equation 2, and call this equation 3. All right, I believe it's clear. So now we say let A be equal to 1. Remember what I told you in the previous video. One variable has to have a value, and that variable should be A. It's not as if other variables can't, but the reaction will not be balanced. So we have to let A to be equal to 1. Now let's start with the first equation. The first equation here will say 2A is equals to C, right? So it means that 2 times 1 is equals to C. So it means that C is equal to 2. We have been able to get C. Let's look at the second one. This is equation 1. Let's look at equation 2. 6A equal to 2D. Equation 2. All right. What is A? A is 1. So we see 6 times 1 equal to 2D. So it means that 6 will be equal to 2D, right? So to make this right to a formula, we'll divide both sides by what? By 2. 2 will cancel 2. So it means that D will be 6 over 2, which is what? 3. We have gotten D to be 3. Now, moving forward, let's look at this, the last but not the least reaction, so we can get B. So we say 2B is equals to 2C plus D. This equation 3. All right. So how do we get B? We say 2B will be equals to, what is C? Remember, C gave us 2. So we say 2 times 2 plus, what is D? D is 3. All right. Take it step by step. So this is 2B equals to 4 plus 3. All right. So it means that 2B will be equals to what? 7. To get B, divide both sides by 2. 2 will cancel 2. So it means that B is equals to 7 all over 7 over 2. Are you seeing now that we are now having a fraction? We got B to be equal to 7 over 2. D is 3. C is 2. And of course, we say let A be equal to 1. But now this fraction that we have gotten here will affect our reaction. Because when we are assembling it into the general reaction, we cannot put a fraction. You can't come here and say replace this b with 7/2. It's wrong. Okay? Every reaction should have entities that have coefficients of whole numbers. So in this case, what do you do? Simple. Multiply the denominator of the fraction by everything you initially had. What do I mean? What's the denominator of the fraction? 2, right? Multiply 2. Why are you multiplying 2? You're multiplying 2 so you'll be able to cancel out the fraction, because 7/2 times 2 will give us 7. But it's not only the fraction. Note, it's not only the fraction that you will multiply it by. Multiply it by everything. A, C, D. Then, of course, the fraction itself. Now, what if you had two variables that gave you fractions? For instance, now, what if this D were to be 3/4? What do you do? If you have 2, if you have 3, even if all the variables are giving you fractions, what you have to do is simple. Take the LCM of the fractions. Take the LCM of the fractions, like the LCM of the denominator. For instance, now if this D were to give us 3/4, take the LCM of 4 and 2. LCM of 4 and 2. 2 here, 2 here, 1, 2, 1, 1. Of course, it's 4. 2 times 2, 4. So now you use that LCM that you take now, that you now have to multiply through by everything. But if it is only one variable that gave you a fraction, just take only the denominator. There's no need looking for LCM of only one fraction. It's when it is more than one, like 2, 3, you take the LCM. When you take the LCM, you will now use it to multiply through all the variables that you initially got, so you can be able to cancel out the fractions. So in this case now, we have b to be equals to 7/2, and the denominator is 2. So we have to multiply everything here by these 2. So what do we say? What we say now is that a, which was 1 before, will now be 1 times 2, which will give us 2. Okay? C, which was 2 before, will now be 2 times 2, which will give us 4. D, which was 3 before, will now be 3 times 2, which will give us 6. While B, which was 7/2, will be 7/2 times 2. 2 will cancel 2. Our answer will be 7. All right? So it means that these are our final values for the variables: 2, 4, 6, and 7. So what do we do here now? We write our balanced reaction. So now we come here, look here. Okay, we can now change these variables. Okay, we can change these variables to their values. A gave us 2, so we say 2. Okay, B gave us what? B gave us 7. We'll come here, we'll write what? 7 here. Okay, we'll write 7 here. So it means that we have 702. Okay, C gave us 4. We'll come here, we'll write 4. While D gave us 6. We'll come here, we'll write 6. All right, but that's not all. You have to check if it's balanced. So carbon here is how many now? 4, right? Remember, carbon was just 2 before, but carbon is 4 here now. Carbon is how many here? 4 as well. All right. Hydrogen is how many here? Hydrogen is 2 times 6, 12. Hydrogen is 6 times 2, 12. Balanced. Oxygen, 7 times 2, 14. Oxygen here, 4 times 2, 8. 8 plus 6, 14. You can now see that this equation is balanced. All right. So if you have any question whatsoever, ask your question in the comment box below. If you found this video very educative, you can, of course, like the video. All right. So I'll be dropping an exercise right away, of which you should balance. Okay. Like I said, my WhatsApp contact, how you reach me, is through 08140906243. And of course, my name is Nisike. This is Nisike Academia. If you're not subscribed, do well to hit the subscribe button and of course get more notifications. So I'll be dropping the question okay, right away. All right. So these are the equations, these are the chemical reactions that you balance. So balance this and balance this. All right. So follow the steps. And of course, these steps will definitely help you to ensure that these two reactions are balanced. Okay. You can also share this video and also do well to always be notified. Do well to stay notified, stay all informed about the videos, okay, that will be uploaded. Ensure you've subscribed, hit the subscribe button, and also like this video. Ask any question. Feel free to communicate with me anywhere you find confusing. All right. Thank you. See you in the next video.